Hello dear students, today we are going to have a really interesting and useful lesson. We are going to learn how to work with CompletableFuture. This is something what personally I use very often when I work with multithreading, and in my opinion, this class and its features underestimated among engineers. So today I am going to show you how powerful this type is and when we may use it. We are going to learn how to execute tasks with CompletableFuture. During the lesson we'll learn the concept of the callback and how to work with callbacks with the help of CompletableFuture. Besides that, today we are going to learn more advanced concepts, namely, I'm going to show you how we can combine future objects together and work with them. And at the end of the lesson, we'll learn how to manage exceptions in CompletableFuture. Let's start learning this topic with the help of official documentation and the source code. Let's understand first what CompletableFuture is and what problem it solves. Creating multi-threading programs is not an easy thing. Especially, it's hard to manage asynchronous computations and build dependencies between those. In case you have multiple steps in multi-threading program and each step may depend on execution of the previous step, you try to find out ways how to implement this in code. It may end up with having multiple callbacks and logic may be scattered across the application. And what about handling errors that happened on one of the steps? Should we handle the same error in different places, or we can find a way to create an exception handler for multiple connected steps during multi-threading processes? CompletableFuture helps us to solve this issue and even more. CompletableFuture was released in Java version 8 to improve Future interface. Future interface was released in Java version 5. It was a great improvement, but its introduction doesn't solve an issue of connecting multiple tasks between each other and API for error handling. Along with Future interface, CompletableFuture also implements another interface that was introduced in Java version 8. It is called completion stage. This type defines the contracts for behavior for an asynchronous computation step that we combine with other steps. In the source code of this type, you may find a lot of different methods, most of them are overloaded. So implementation of completion stage and future interfaces in CompletableFuture gives us around 50 methods available to use. Those methods primarily for composing, combining, executing asynchronous tasks and error handling. Let's start watching CompletableFuture code examples. I created separate package for examples only with CompletableFuture. I shared the link to the package with you in attachments to this lesson. In the demo number 1, I am going to show you the simplest and probably one of the most popular usage of CompletableFuture. It is super easy to run asynchronous tasks with this type. It has multiple static methods that allow us execute tasks in a separate thread without long configuration of a thread object or creation of executor service and shutting down it later. In case I just wanna execute asynchronous task, I just call runAsync static method of CompletableFuture class. That's it. For example, you just need to notify another service about work being started or done, and you don't care about response from the client. Such similar cases may happen sometimes. When you call runAsync, fork join common pool is used. This approach is good for intensive and fast tasks. Considering the fact when Java process is finished there is no common pool, I put sleep here to let the thread be executed and print the stacks to console. RunAsync method is overloaded. There is a method that takes runnable object and executor as method argument. In the next example here I pass the same lambda function for runnable and executor service. Considering the fact that second example here uses separate executor service and doesn't use fork join common pool, I don't need to put any sleep here to not afraid Java process termination. And you can see in console thread name and console output that imitates some work that may be done in a separate thread. By the thread name you can understand that thread is executed with the help of fork join pool. Make sure you watched my lesson about fork join pool if you want to learn more about it. In the second case we use thread pool executor, that's why thread name is different. That's it regarding this example. Let's move on. The next example is related with one of the features of CompletableFuture type. You can complete task with method. To be honest, I have never used this method beside learning and educational purposes. But this method is like one of the main things in CompletableFuture. when you potentially need to use it. Let's say you need to fetch some data from another server. This operation would take some time. That's why you decided to run this task in a separate thread. But something happened and the remote server doesn't respond for a specific amount of time, and you already need to proceed with execution. In this case, you may complete the future by returning the default value. Let's look at the example. I want to print to console result of asynchronous calculation. I call method calculateAsync that returns me future object. And considering the fact that CompletableFuture implements future interface, I can return CompletableFuture when needed. I create an instance of CompletableFuture. After that, I create cache thread pool and submit callable for execution. I imitate a call to external server. Imagine that I want to get some price, double value that I will assign to the result variable and will return it. By making my thread sleep, I imitate the delay in request to a server. After that, I shut down executor service, and I call await termination. I am waiting for 2 seconds only. Having the reference to the future object, I can verify whether all calculations are done or not done. If calculations are done, I return the reference to the future object. If calculations are not done, I call complete method on my CompletableFuture object and I pass some default price value that I am happy to return. In this case, future won't be done. And we are going to have false here. Because we wait termination only for 2 seconds, but we expect task to be completed in 5 seconds. After calling complete method, CompletableFuture will be considered as completed. And I return the reference to the CompletableFuture. When I get the reference to the future, I just call get method and I extract completed result. Let's run this program. And you can see that in console we have 9.99. This is our default price. And we don't get new value. Is it clear? If no, ask question below this video and I will be happy to answer. If everything is clear for you, then let's proceed. The next example is located in the file with name demo3. This time I am going to show you supplyAsync. Similarly to the runAsync method, we can submit a task without boilerplate code. But the only difference is that in runAsync we passed runnable object, and here we need to pass supplier. In case you're not familiar with supplier type, feel free to watch my course about functional programming for Java engineers. In that course we have plenty of examples that will help you to understand a lot of functional interfaces, including supplier. Basically, that's it. Supplier returns the value. That's why I can get future after calling supplyAsync and extract result from it. Let's run this program and print result to console. And as you can see in console, I managed to extract text from the future object and printed it to console. So feel free to use this method in case you have something to execute in a separate thread and you need to get the result of the execution. Hope that this example is clear. Let's move on. Now we'll create with you a sequence of steps that should be executed one after another in a separate thread. Because it might happen that you need to perform another action based on the previous step completion. So basically you connect CompletableFuture, which should automatically get called when the future completes. That is also often called a callback. It is also known as call-after function. We have 3 methods that allow us to do this: thenApply, thenAccept, thenRun. We are going to review examples with these methods now. Let's start from thenApply method. In the file demo4, I create super simple example to help easily understand how this works. The pattern is the same, so you can apply it to any other tasks and calculations. Imagine that you want to fetch user ID by email from one API, and once you have user ID, you can request total number of purchases for this user from another API. And you need the result of first task execution to get ID in order to be able to execute the second request. I call supplyAsync to submit my first task. This is supplier that produces some result. And after that, I call thenApply method and pass a function that takes result of previous task execution as an input argument, and that returns other value. I have console output in first and in second task just to imitate some work. The result of thenApply method is a future object that you can use to retrieve result of computation of last step. You can build multiple steps like this by calling thenApply and using the result of execution from previous step as an input argument for the next step. Is it clear? If yes, then great. Also, there is another similar method, thenApplyAsync. What would be the difference between thenApply and thenApplyAsync? Basically, the main difference is the executor that is used to execute these tasks. By default, thenApply method uses the same thread that was used by the first task and uses the same executor that was defined by CompletableFuture on which it is called. thenApplyAsync uses independent executor. By default, it is fork join common pool, but there is an overloaded method that allows you to pass executor service. Like in the similar example below that will bring us to the same result, I use executor service in thenApplyAsync method. In general, if you have multiple tasks for execution, I would just recommend you to have executor service configured and use it for tasks execution. That's it regarding thenApply method. Let's move on. I open demo5 file. So, as you already understood, thenApply method returns you some future object. But in case you don't want to create return statement to return result of the execution after the final step, and you just need to have some code got executed, you have to use either thenAccept or thenRun. We are going to talk in a minute what is the difference between these two. Let me just start explaining of thenAccept first. In this case, imagine that we need to extract full and complete user profile, and in the first step of multithreading process we received text representation of user profile. And after that I just call thenAccept method to perform some operation that doesn't require me to return a result. For example, just saving this information somewhere in the application, probably in the user session object, or in local database, it doesn't matter for this example. thenAccept also returns CompletableFuture, but this is CompletableFuture that is parameterized by void type. In case you would try to extract value from this future, you would get null. Let's run this program. And as you can see in console, I printed to console null. So we can say that extract value from the future after calling thenAccept doesn't make a lot of sense. Similar to the previous example, thenAccept method has methods that allow to use separate executor for each step. thenAcceptAsync method uses separate executor for tasks execution. Is it clear? Now let's look at the next example with the run method and understand how it is different. I open demo6, almost similar example, but in this case, I just want to save user profile to another server, and when this task will be executed, I want to log that user profile has been saved or perform any other actions after the first one. In this case, there is no need for me to call supplyAsync, because the result of computation of the first step will not be passed to anywhere. That's why it wouldn't matter at all what value will be returned from the first step of the execution. And after it, I just call the run method to perform some actions. In this case, just to notify that user profile has been saved, and I can proceed with other operations that were dependent on the first one. And again, we have future object returned, but it contains nothing in response. And also we have similar method to thenRun, which is called thenRunAsync. This method will use separate executor service, either fork join pool or the one that is specified. Hope that you understand now how to work with these methods. Let's continue. I'd like to talk about combination of different future objects. I open demo7 file. Imagine that you already have two methods, and both of them return CompletableFuture object. The first method extracts user details by ID, and the second method extracts credit rating by user details. You already know how to use thenApply method. Let's look how it would look like. In this case, when you would call one method and after that you would call another method that also returns CompletableFuture, you would get as a result CompletableFuture that is parameterized by CompletableFuture. It is not too convenient to work with the result now. You should call get method twice to extract the result that you wanted. Especially for such cases, there is a compose method. In case I call thenCompose instead of thenApply, I get completable future parameterized by the type of my result. And that's it. This solution is more elegant in case you wanna compose one future object out of two. If you know Stream API in Java, I am sure you remember that there is such method as flatMap. That method is similar to this one, so you can extract completable future from another completable future and get flat representation of the result. Also in this case we have one task running after another, so two dependent tasks. We have also similar methods that are called thenComposeAsync. I believe you already understand what is the difference. thenComposeAsync use separate executor. Let me open demo 8 now. In case two tasks are independent and you just want to complete two of them in any order, you can call thenCombine method. In this case, you can perform some actions after two tasks are completed. So again, we have two methods that return completable future. One method returns wait and another method returns hide. Each method has sleep for 1 second inside. This is just to imitate some operation time. In main method we get wait in kilogram future, and after that we call thenCombine method and we pass hide in centimeters future there, together with by function. As you remember, by function can take two arguments and return the result. These two arguments would be the result of these two future objects. And once we get the result, we apply the function. Inside the by function, I wanna calculate body mass index by following specific formula here. Let's run the program. And you can see in console that after retrieving weight and height, I start calculating body mass index. And the main thing here is that I don't need to have connection between execution of the first and the second task. They can be executed in parallel, but I just need the result of both computations. And following convention, we have thenCombineAsync method, which is overloaded and has a version with default executor and with a separate executor argument. I open demo 9 file, and you already know that thenCombine method returns the result of computation of two future objects. We have another method that is called thenAcceptBoth that instead of by function takes by consumer. That means it doesn't return any value and just consumes the results of execution of two tasks and works with two future objects and return nothing. So in this case, you can see that I supply lambda expression that returns first, I call acceptBoth, and after that I supply lambda expression that returns the second. And we just print concatenated string to console. And in case I would extract the value from the future object, I would get null, because thenAcceptBoth method returns completable future parameterized by void type. Let's run the program. And you can see that I printed concatenated string. The null value proves that my future contains nothing. Also, we have similar method following conventions. We have thenAcceptBothAsync method. So far we learned methods that allowed us to combine only two completable future objects. Now we are going to learn methods that allow us to combine multiple completable future objects. There are two methods, allOf and anyOf. Both of these methods accept variable arguments of completable future type. Let's review these two. I open demo 10. We have here a simple but very interesting example. We are going to cover with you a few more methods that I didn't share with you before. The goal of this example is to create a list of strings and turn them into capital case. Pretty simple scenario. And we will solve this task with completable future, not because I love complicating things, but just to help you understand this example. I create list of strings. After that I create string from this list. I call map method and pass in function there. Completed future method returns a new completable future object that is already completed with the given value. After that I call thenApply method for each string and invoke delayed uppercase. Delayed uppercase sleep for a random amount of time but up to 1 second, and returns the current string in uppercase. This random sleep imitates some operation time in case there would be more actions here. After that we have list of future objects. I call allOf method and pass array of future objects. considering the fact that allOf method may accept variable argument. allOf method will return new completable future that is completed when all of the given completable futures complete. But what would happen in case one of the given futures complete exceptionally? Then the returned completable future also does so. The results, if any, of the given completable futures are not reflected in the returned completable future, but may be obtained by inspecting them individually. After that, I call whenComplete method. This method returns a new completion stage with the same result of exception as this stage and executes that given action when this stage completes. WhenComplete takes byConsumer as method argument. In this byConsumer, we receive the result on null if none, and the exception on null if none of this stage as arguments. To get the results, we need to go over our features one more time. In this case, I just print each updated string to console. Pay attention that I call getNow method of CompletableFuture. We didn't discuss this method yet. GetNow returns the value if computation is finished and returns default value that we pass as method argument if result is not ready. In our case, we use whenComplete method, so we assume that all of the features were done by this moment in our program. So I print all uppercase string to console. Let me run this program. That's it. Any questions regarding allOf method? Leave them under the video in case of any. The next demo is related to anyOf method. Let me open demo 11 file. Here we have absolutely similar example but with only one difference. Instead of allOf, I call anyOf method here. anyOf method returns a new completable future that is completed when any of the given completable future complete. So in this case, the first future that will be completed will be printed to console. Let me run this program. That's it. I have been processed first and that's it. Nothing else is printed to console. Does it make sense? Great, let's proceed. And the last but not the least for today, I am going to show you how to handle exceptions with the help of CompletableFuture. This type allows us to handle errors in a chain of asynchronous computation steps. Instead of having try-catch block, we have handle method that receives two arguments. The first one is a result of computation, in case all processing was finished successfully, and the second argument is exception thrown in case there was some exceptional case. I open demo 12 file. In this file we have examples of error handling. I supplyAsync the next task. I have int variable that is equal to 5, and I divide it by 0. We are going to have arithmetic exception in this line. But take into account this is runtime exception, compiler doesn't warn us about potential handling. But I'm smart enough to call handle method after the last step. And by the way, you may have multiple steps, handle method will catch exception on any step of execution. In case there are no exceptions, result of execution would be in the first argument. And in case there is an exception, I have the reference to the exception object passed as the second argument. Let's run this program. And in console output we can see that we entered this if block. I printed class of the exception, it is completion exception, and it is caused by arithmetic exception, so we can see how completion exception wraps the original exception. We have also another method for error handling, it is called exceptionally. The difference is that it takes not by function like handle method, but it takes function and has parameter of throwable type. The same way I check exception here, and considering the fact that I don't have any result available, I can return some default value, for example. That's it. We learned a lot about CompletableFuture. In case there is anything else you want to know about CompletableFuture, please ask questions. Now, let's recap what we have learned in this lesson. In this lesson we learned CompletableFuture. As I said in the beginning of the lesson, it is a very useful class that I use very often when I work with multithreading. It helps to solve a lot of pain points. We learned different methods that describes how to execute tasks with CompletableFuture. Also, now you know what a callback is and how to work with callbacks with the help of CompletableFuture type. We managed to build multi-step multithreading processing. On real examples, you saw how we can combine future objects and work with them. And at the end of the lesson, I explained how we can manage exceptions with CompletableFuture type. That's all for this lesson. Thanks a lot for your attention, have a great day, and see you in the next lesson.